Hello, I'm Ryan from High Desert Math Tutor, and today I want to talk to you about the exterior angle theorem. Now, before we begin talking about the exterior angle theorem, I want to begin by making sure we have some common ground with the definitions of exterior, adjacent, non-adjacent, and a few extra words. So to begin, the word sum. Many people have heard of sum, difference, product, quotient, but I just want to make sure we're very clear before we jump into the theorem. A sum is the answer you get when you add numbers. So a sum is the answer you get when you add two or more numbers. Okay, now the next important definition we need to be very clear on is the meaning of adjacent. So adjacent is a word you hear in geometry, you hear this in trigonometry, and many other classes after those two. Adjacent just comes up naturally. So adjacent is very simple. It just means next to. So two things are adjacent if they're next to each other. If two things are not adjacent, that just means they're not next to each other. So adjacent means next to. Oops. It means next to. Oh my gosh, I'm sorry, I cannot write right now. Or it means beside. Okay, so adjacent means next to or beside. Non-adjacent means not next to or not beside each other. Okay, last two definitions, then we can jump straight into this theorem. It'll be pretty fast. So the next definition is exterior. Exterior means outside. So you may hear someone say exterior of the building or an exterior of a car. So exterior in this context means outside of the triangle. And our final definition is interior. Interior is on the inside. So interior to the triangle would be the inside of the triangle. Okay, so with that being said, now we're ready to discuss the exterior angle theorem. So what the theorem says What the exterior angle theorem says is the exterior angle of a triangle is equal to the sum of the non-adjacent interior angles. So we have quite a bit to break down. So the exterior angle of a triangle. So here, if we look at this triangle, notice there are three angles on the inside of the triangle. Then we've extended one side of the triangle, and here there's one exterior angle, so an angle on the outside of the triangle. So the exterior angle theorem says we're focusing on this exterior angle, and this angle is equal to. So recall, equal means is the same as. So this exterior angle is the same as the sum of the non-adjacent interior angles. So many, many words. So sum. And now we're focusing on the non-adjacent interior angles. So non-adjacent means not next to. So since we're focusing on the exterior angle, 60 degrees is adjacent to 120 degrees because these two angles are next to each other. This 40-degree angle is not adjacent to this exterior angle because they're not literally next to each other the way these two are. Next, this 80-degree angle is not adjacent to the 120-degree angle because they're not next to each other. So these two angles, 40 and 80 degrees, both of those would be non-adjacent to the 120-degree angle. But not only that, these are interior angles because they are inside of the triangle. So to reiterate, the exterior angle theorem says the exterior angle right here of a triangle is equal to, or it is the same as, the sum of the non-adjacent interior angles. So to write this in equation form, what we're saying is the 120-degree angle on the exterior is the same as the answer you get when you add the two non-adjacent interior angles. So we take these two non-adjacent interior angles, when we add them together, that should be the same as this exterior angle, which is 120 degrees. And if we check, 120 degrees is the same as 40 degrees plus 80 degrees. That's 120 degrees. So those are in fact the same. So now if we look at one additional triangle, this will be one that we can kind of utilize our knowledge of this theorem. So let's say that we do not know what this angle right here is, but we know that this angle is 30 degrees and this angle is 70 degrees. We don't really need to find this extra interior angle. So we have something we don't know that we want to find, but we know something about these two interior angles that are non-adjacent to the exterior angle. So we can use the exterior angle theorem to put together an equation, and once we have an equation, we can just use the algebra we know to solve the equation. So what we can see now is the exterior angle is equal to, or is the same as, the sum of the non-adjacent interior angles. And we can see x is the same as 100 degrees. So that means this exterior angle is 100 degrees. Let me give you one more example. So I can also, and the orientation doesn't matter, I could draw something like this if I want to. So let's say that this is 50, and then this is, oh, I'm sorry, let me say something other than 50, make it a little bit bigger. Let's say it's 150. Let's say that this is unknown, and this one over here is 45. So outside of the triangle, we have an exterior angle that is 150 degrees. Inside the triangle, we have two non-adjacent angles to this that are interior. So we can use the exterior angle theorem, to say that the exterior angle, 150 degrees, is equal to the sum of the two non-adjacent interior angles. Now we see here we have an equation, but notice that the x is in a different position because the unknown angle is one of the interior angles, whereas in this triangle, the unknown angle was an exterior angle. So the exterior angle is always by itself. Here, the exterior angle is always by itself when we're using this theorem. So now that we have an equation, we can solve it. We don't have to really stress out how to move forward. We just go back to our knowledge of algebra. So we look at what's happening to this unknown variable. We're adding 45 to this. And we want to undo this so we can get it by itself. We undo adding 45 by doing the opposite of adding, which is subtracting 45 degrees. But remember, if we subtract 45 degrees from the right side of the equation, we have to subtract 45 degrees from the left side of the equation. So we've chosen to subtract so that those will cancel. And what we get, all that's left over on the right side of the equation is x. And what's left over on the left side of the equation is 105 degrees. So this is how we use the exterior angle theorem in most of the formulas and theorems that we know. What we do is we look at a problem that we're trying to analyze or solve. We use these theorems to help us turn the information we have into an equation. And then with this equation, we can either simplify the equation or we can take the equation and we can solve it for what we don't know. So this is how we use the exterior angle theorem.